we're now going to consider the birth date of this person and get closer to date functions. The correct date is constructed by using function date parenthesis begin, and as we see from the lower portion, it expects from us a year's number, month's number, and day's number, and these are all within the Social Security number. So far, when we've taken text from within Social Security number, we used left, and furthermore we have used in this sheet functions right, length, find, the and for joining together pieces of text, and now the last function we're going to use is called mid parenthesis begin, and this takes text from the middle. It asks from us again, we see from the hint, it asks from us for a text, which is B17. Now, the next thing is, we want to take the second and the third number. We want to take the second and the third number. And in mid, it has to be written like this, semicolon 2, semicolon 2. So it says that we want to take from the second two numbers, and it takes the second and the third. Okay, semicolon, and now we're down to a month's number inside the date. And another mid is needed. Mid, parenthesis begin, B17, semicolon, and now we need the fourth and the fifth character from inside the Social Security number. So it's semicolon 4, semicolon 2. And we get the month's number extracted as well. The last thing to do is the day's number, which is semicolon here. We're still continuing our date, and the third mid goes in there. Mid, parenthesis begin, B17, semicolon 6, semicolon 2. And here it is. Now we have completed our date. The first mid is the first thing going into date. The second mid is the second thing. The third mid is the third, so to say, parameter. And we have them all nicely lined up here. We take from the second and third, fourth and fifth, and sixth and seventh characters. Okay, so these dates come up just about nicely. Of course, again, here is a additional constraint, namely these are all from the 20th century again. If we had wanted to create some dates that were from 21st, our formula would have been more complex. And now to show a few more things. When we're considering dates in Microsoft Excel, and this is going to be entirely new material, we write the 1st of January 1999. And if we write down also the 3rd of January 1999, we can do such a thing that we can subtract one from another. So if we write 3rd January minus 1st January, we get the number of days between these two dates. Okay, if we can subtract the dates from each other and get the number of days between the two, it means that our calendar of Microsoft Excel should also begin somewhere. The only thing, the first question, does it begin with the birth of Jesus Christ? No, it doesn't. Namely, the calendar of Microsoft Excel begins in the 1st of January 1900. Well, Excel was created in 1980s. I guess the time horizon was such that the first date considered seemed to be logically to be taken as the 1st January 1900. So it means that if we take the 14th of February 1900, we can do such a thing. Go to that first date, Control 1, and turn it from a date into a number. And it's number 1 because it's the first day. The 14th of February 1900, if we take it from the date and turn it into a number, is going to be 45 because this is 45 days after the beginning of our calendar. Now, if we take the 1st of January 1900, take it from the date, turn it into a number, it's going to be 36,161, which means that in this first 100 years, we had around 36,000 days. Okay, so all the dates are numbers from the beginning of the calendar. They can be subtracted from each other. Let's use it to create an age for our person with the social security number. We're going to write equals, and now comes another new function. It's called today. As it always returns just the date for today, it has nothing in its parentheses, and we're going to write today minus the birth date of this person, F17. This gives us his age in days. His 11,000 or so days old. Now let's take this and check for his age in years, and we have to guess how to do that. And after a little thinking, we can come up with the answer. We put parentheses around the subtraction, and we divide it by 365, the number of days in 1 year. Now there's a problem though, and this problem is that there's one extra day in every 4 years, so we have to divide it by 0.25. 365,25. Okay, let's write with this formula at the moment. So if we press enter, we get an H, but this seems to be a wrong H, because today, at the moment of this recording, the date is somewhere in the end of 2011. So this person should really be already, or be still, his age should be 30 years. Not yet 31 years. Okay, where's the problem? Now this is important. You see, the problem has been introduced by the fact, when we go to the cell and press Ctrl 1, it's been introduced by the fact that it's considered as a number with 0 decimal places. This means that Microsoft Excel, even if it has decimal places, this number is going to round this number. If we show the decimal places, it's actually this person's age is 30,845 days. And if we round it, we make him older from the day he gets half a year old, 30,5. We make him older, we make him into 31 years old. So this doesn't naturally work. And as we see, the errors can even be introduced by this Ctrl 1 key press. Okay, let's leave it with decimal places. And now what we need to do, this is something we've actually already done. We need to take this formula and put we need to round it down, which means that we always cut away the comma places. We never round it up, always down. And this function we already had with random numbers. It was called int, which stood for integer. Here it is. Now the age is correctly 30. We're going to copy it as well. But there is one more point to be made about this. Namely, if we take a person who was born exactly today, let's say 30th of September 1974, or let's say 75 in the beginning. And let's take away this integer and let's see what it exactly does. We took away this rounding. You see, what happens is that a person who has a birthday today, for him we add 0.25 days every year. So it's 365,25. We add 0.25 days every year. But actually, we should only add 1 day every 4 years. So his age right now, 1974, he's gonna be 27, is, since we used this 0.25, it's almost 27, and it calculates it wrongly. I'm going to take a person who was born in 73. Again, the same kind of error. 72, the same kind of error. And only when he is exactly 40, so when his age is exactly divisible by 4, 40, or a person who was exactly 36, only these birthdays does your age get calculated correctly. So once again, because we're adding this 0.25 every year, there are actually, out of every 4 years, this Excel formula will give you a wrong age in 3 of your birthdays. Every other day the age is correct. Every 4th birthday is correct as well. But 3 of your birthdays is actually, the age will be shown in a wrong way. There's even one more thing. Once in every 400 years, like the year 1600, or the year 2000, there's a further exception to having extra days, to having 365 days. So there are such small exceptions. We can almost always use this formula that we had, but not in 3 birthdays out of your 4-year entire period. Okay, I'm gonna copy this formula to get the initial date back. Okay.